This is going to be a quick review of sections 1.1 and 1.3 for build up to our exams. So, section 1-1. There's really just a few big things that come out of this section other than the basic undefined terms. What is a point? What is a line? What is a plane? The big things, however, deal with angles and segments. And when we're talking about these angles and these segments, what we're really concerned with are three situations. First, how do we measure? Second, um, second being uh, addition, and the third one being notation. So, we measure angles, as we know, using a protractor. Addition, this is going to be easier to kind of look at a picture. If we have a picture like this, then this angle, then this angle right here, and this angle right here can be added together. But the key thing is they have to be attached. They have to share a common edge. And then the notation for the measurement of an angle is like that, where this part here is the actual angle itself. As long as the meaning is clear, we can actually shorten this down to be like the measure of angle B. Like if there's no confusion about what that might mean, we can definitely go that route. Segments we measure, of course, with a ruler. For addition, as long as they have a point between two others, so A, B, C, we can take this segment and add it to this segment here. So we can take segment AB and add it to BC. But this has to be a situation like this. They can't be separate segments. And there are a couple of ways that we can do this. Measurement of AB, this is correct, as is this. Oftentimes we will just see it as AB equals whatever the measurement is. Sometimes we drop this in, but the point being, we have to define a segment using 2 points. Unless we have a situation like, let's say this is X, then we can just refer to that segment as X. But it's very uncommon. It's much better to refer to it as 2 points. And that's the important bit out of the first section. Just remembering really this addition situation for both and the notation. 1-3 has two big things in it. First is midpoint. Now, midpoint has a formula which is not that bad to remember. You can remember it two ways. Either the average of x, comma, the average of y, or we can remember it as x1 plus x2 over 2, comma, y1 plus y2 over 2. Then we have distance. And with the distance, we could think of it in a couple of ways. If we have 2 points and the segment between them, I'm just going to move that point up, we could picture this as a right triangle. And by doing so, we could just find the length here, which would be x2 minus x1. If this is my point 1. And this is my point 2. To make it to where we don't have to worry about the order, we could just always put absolute values. For our vertical, we could break this down as y2 minus y1. And if we take the absolute value, we don't have to worry ourselves about if it is going to end up being positive or negative. So if we go about it this way, we could simply say that this is b. We could say that this is a, and we can go a squared plus b squared is equal to the distance that we want squared. So we're looking for distance. And that's reasoning through it. You can also just follow the distance formula. And I know that some of y'all prefer remembering formulas as opposed to the underpinning aspect of it. But d is equal to square root x2 minus x1 squared plus y2 minus y1. y2 minus y1 squared. So these two formulas are the key out of 1-3 that we need to remember. To get a example, we have -2, 3, and 4, -5. We have this set up here. The midpoint, I'm going to call that M. This will be point A, and this will be point B. So the midpoint of A and B is going to equal the average of my x's. So that's, I add the two numbers together and divide by 2. So 2 divided by 2, which equals 1. And then do the same thing with y's. 3 and that, so -2 over 2. So our midpoint is the point 1, -1. The distance of AB, I'm going to just plug everything into the formula this time, but we can do it either way. So I'm going to say B is my point 2. So 4 minus -2 squared plus -5 minus 3 squared This is going to be equal to square root of 6 squared plus negative 8 squared. And 6 squared is 36. Negative 8 squared is 64. And this is going to add up to be 100. And the square root of 100 is 10. So the distance that we're dealing with can be found using the formula. We could have used Pythagorean's theorem. Okay, that will do it for this video. The next video for the review is